Continuing on, let's talk about the analysis of variance, or abbreviated Anova. You might have heard of this. Analysis of variance Anova. This is a parametric statistical procedure where more than two groups for comparison and more than two conditions under which each group is tested. The F ratio is the statistic that is calculated, and the outcome of the analysis is usually reported in the summary table. To interpret the F value, you would take the ratio and look at a special significance table. You don't need to do this anymore. Now the computer does this all. And a p-value will be reported for each F. So an ANOVA tests for differences among several means. If there is a difference among a set of group means, then the variance between the groups will be significantly larger than the variance within each group. The variance between the groups can be thought of as the variance of the group means around a grand mean of all the scores. Once you see the table, this will make more sense. So a researcher might, for a one-way ANOVA, a researcher might ask if children of different ages differ in their performance on some language task. Using a cross-sectional developmental approach, the researcher assembles four age groups, a group of 105-year-olds, 106-year-olds, 107-year-olds, and 108-year-olds. And then they assess the performance of these 400 children using a one-way ANOVA design. There's one independent classification variable, and the structure of an ANOVA, or the number of ways it tests for mean differences, is determined by the structure of the independent variable in the study. So we have four groups of 100 children, right? There's going to be some variation among those 100 groups in their language scores, or whatever we're looking at. So we're going to calculate an age group mean for the 5-year-olds, the 6-year-olds, the 7-year-olds, the 8-year-olds. An age group variance, so how much each score varies from the mean. And then we're going to look at the variance between the age groups. So not just the variance within the 5-year-olds and the variance within the 6-year-olds, but we're going to look at the variance between the 5 and 6-year-olds, between the 5 and 7-year-olds, between the 5 and 8-year-olds, between the 6 and 7-year-olds, get it, between the 7 and 8-year-olds. If the variance between the groups relative to the grand mean is much larger than the variance within each age group, there'll be a significant difference among the age groups. And you'll see that in the F ratio, and you'll get your statistic. The F ratio that results is the ratio of between group variances, called the mean square between groups, or mean squared between, to the within groups variance. When the between group variance is much larger than the within group variance, the F ratio is large. It reaches statistical significance when it's large enough for the appropriate number of degree of freedoms and the alpha level. When the between group variance is not larger than the within group variance, so when the difference between the 5 and 6-year-olds is not as large as the difference within all the 5-year-olds or within all the 6-year-olds, then the F ratio is small and that does not reach statistical significance. So here's a figure to help you better understand. So our independent variable is age. A group of 105-year-olds, 106-year-olds, 107-year-olds, 108-year-olds. We're going to calculate a mean for each group. We're going to calculate the variance, so how much each individual score varies from the mean. And then we're going to look at the differences between Group A and Group B and compare it to the variance within Group A. The null hypothesis, the HO, is that there is no difference in the means of the four groups. The hypothesis, not the null hypothesis, is that there is a difference in means of the four groups, which is what you're interested in, but remember you have to test the null hypothesis. So when we're doing statistical testing, what we're actually doing is showing that your results, you're disproving the null hypothesis by showing that your results could not have happened by chance. And here we go again where they calculate the summary table for between groups and within groups, and then they look at the variance. And then they find the F ratio. So the observed F ratio of 3.1 falls between that required at the 0.05 level and that required at the 0.01 level. Therefore, there is a statistically significant difference among the four groups. The difference could only occur by chance fewer than 5 in 100 times, but more than 1 in 100 times. So your P level is 0.05. You weren't able to hit 0.01, but you still hit 0.05. So you can reject the null hypothesis and accept yours.